Okay, so this video we're going to go over linear functions. So a linear function is a function whose graph is a line. Right, makes sense, right? Linear functions in the form that we will be using function notations, right? Linear functions, they can be written in the slope form, right? The slope intercept form. Okay, the slope intercept form looks something like this. F of x equals to mx plus b, where b represents the y-intercept. Right now, we say b, but the y-intercept is in fact a coordinate, so 0 comma b is the y-intercept, right? Where the x-coordinate is 0, right? And that gives us where it crosses the y-axis. Right? And m is the constant rate of change. Right? So it tells us if the line is changing, right? The change is constant, meaning that at each point it is changing at the same exact, let's say if we were at when x is 2, it's changing at the same exact rate if x were negative 5. Right? So that's what we mean by constant rate of change. Okay, that it's not changing in a faster manner in a certain part along the graph. It is, the change is constant, even though the function itself may not be throughout the interval. Right? Sometimes this is also known as the slope, right? Or change in y over change in x. That's how other ways that we classify our slope. Okay, so again, f of x, sometimes y if we're not using function notation. All right. Now we do gather a lot of information from these particular values, right? The y-intercept tells us where it crosses the y-axis, and m tells us how quickly or not so quickly the line is changing, right? Or whether it is changing in the positive manner or a negative manner. Right? Now, if m is equal to 0, there is no change, right? The variable would go away and we really would have just a constant. We'd have a constant function, right? So when m is 0, that corresponds to no change. In other words, we have a constant function. If m is negative, right, less than 0, then we have it is decreasing. Right, that corresponds to a negative slope. If m is positive, then that corresponds to an increasing function, increasing linear function. Right? And we have a positive slope. Okay, so let's work an example here where we calculate the slope and maybe find the equation of a linear function. And so let's say for this example, let's say that we are given that f of x is linear, and 2, 3, and 0, 4 are points on the line, find the slope, and let's find the equation of y. Okay, so let's start off by finding the slope, right? Now again, we define the slope as constant rate of change in y over change in x. Right? So all we need to calculate the slope is 2 points, which is what we have here. All right. Now, when we need a change in y, we need usually the slope is given as y2 minus y1 over x2 minus x1. All right, that is the change, right? The difference in those two values. Now, when you have these 2 points, you're like, well, which one is x1, y1? Which one is x2, y2? You make that choice. It doesn't matter, right? Just be consistent, right? If this is going to be x1, that has to be y1. If this is going to be x2, that has to be y2. Right? That is the only condition. Doesn't matter if we did this vice versa, right? If this is x2, then that has to be y2. Right? Okay, we'll arrive at the same result either way. So let's call this one x1, y1, x2, y2. Okay, so that means our slope is going to be, let's see, y2, 4 minus 3 over 0 minus 2. And simplifying here, 4 minus 3 is 1. 0 minus 2 is negative 2. And I'll just rewrite it in this form, negative 1/2. That would be our slope. So again, knowing what we know now, we have a negative slope. That means we're going to have a decreasing function, a decreasing linear function. Okay. So now we have the slope. How do we go about finding an equation? All right. Okay. So in this case, we're going to use, to find our equation, we're going to use what's called the point slope form. All right. So the point slope form goes something like this. Right, where x and y are variables, m is the slope, and the x1, y1 is a point on the line. Which point? Just any point, right? We just need one. We're given 2, so which one do I choose? Again, doesn't matter. The choice of either one of these is going to lead you to the same result. Okay, so let's just choose 2, 3. So the y coordinate is 3. The slope I've identified to be 1/2. Remember, x and y are variables, so they remain x and y. x1 in this case is 2. All right, now let me simplify, right? Whenever I'm asked for an equation, I'm going to ask for it in slope-intercept form. This is not in that form. So we're going to simplify here by distributing the negative 1/2. Negative 1/2 x. Negative 1/2 times 2 is going to be 1, and we have a negative negative, so plus 1. Right, now we add 3 to both sides, and we get y is equal to negative 1/2 x plus 4. All right, that looks good. And let's use our function notation. We get f of x is negative 1/2 x plus 4. All right, and that is our function f of x. All right, moving on, let's look at let's say I wanted to find the equation. So in this example, find the equation of the line below. All right, let's say that we're given graph. Excuse me, a little sloppy there. But let's say we have this line, and I know 2 points on this line. All right, I know this point, and I know this point here. Okay. All right, and I want to find the equation, right? And again, equation in the slope-intercept form. Now, the nice thing here is, actually, I already know the y-intercept, right? The y-intercept here is 0, 1. That's our ordered pair, which means that based off of that, I already know what b is, right? This is telling me that b is equal to 1. So, excuse me. So that simplifies some of the simplification I have to do at the end, right? I don't have to start with the point slope form. I can jump to the slope intercept form. But for that, I do need my slope. All right, so slope here, change in y. So let's call this y2, negative 5. y1 is 1. So negative 5 minus 1. Change in x, 2 minus 0. And we get negative 6 over 2, which gives me negative 3. All right, so now I have my slope. And again, from the graph, I found b. So I can right away jump to my slope-intercept form. Plus 1. All right, and that's how we find the equation of that line right there. Okay, let's try one more example here. Okay. So for this example, let's say that if f is linear, and f of 3 is equal to negative 2, and f of 8 is equal to 1, find the equation of the line. Okay. All right, now I'm given 2 values of the function, but I can also interpret these as ordered pairs, right? So recall here, something like this. F of 3 equals to negative 2. That is, 3 is the input, the output is negative 2. And in a similar way, here 8 is the input, and the output is 1. I have 2 ordered pairs. Okay, so let's start off by finding the slope. All right, so change in y, so we'll do 1 minus a negative 2, and 8 minus 3. So here we have 3 over 5. Okay. All right, so our slope is 3/5. Now here I don't know, I don't have the y-intercept, so I'm going to start with my point slope form. I'll choose y1 to be 1 here. Slope is 3/5, x minus 8. Okay. All right, doing a little distributing here. And negative 24 over 5. All right, and now add 1 to both sides. 1 I'll rewrite as 5 over 5, and then combining like terms for my last step here, I'm going to do two things. I'm going to use my function notation, right? Y, f of x, 3/5 x, and here negative 24 plus 5 is negative 19 over 5. And that would be my equation. All right, thank you.